Morning to one and all. Now we will see the fast remaining part of the analytical. Just I'm sharing the screen. Okay, it is visible. Now we have to talk about relationship of the fluorescence intensity with the concentration. Here, as we have seen, Beer-Lambert's law has been modified to relate the intensity of the fluorescence and the concentration of the substance that fluorescence. मतलब जो substance fluorescent intensity देता है उसका concentration है. If I0 is the intensity of the incident radiation and I is the intensity of the transmitted radiation, then F is equal to K in bracket I0 minus I. That is equation number 1, where K is the proportionality constant according to the Beer-Lambert's law. Log to the base 10 I0 upon I is equal to epsilon BC is equal to A. A मतलब क्या है? Absorbance. Okay. Epsilon molar absorptivity. Okay. B is the path length, C is the concentration. On substituting in equation wait a minute. Okay. Okay. On substituting equation number see what we have to substitute. We have to substitute K into I0. Okay. See what we are going to do. That just remember these things. F is equal to Ki0 in bracket 1 minus e raised to 2.303 epsilon BC okay. Sorry, just the step is mistaken. Just I am making the correction here. I is equal to I0 minus 10 raised to epsilon BC. I0 is equal to that is equal to I0 10 रेस्ट टू माइनस है. ये आपको समझ में आया. अगर यहाँ का लॉग जाना होगा तो ये एंटी लॉग हो जाता है. 10 रेस्ट टू माइनस एप्सिलॉन बी से दैट एबीसी इज नथिंग बट दैट पर्टिकुलर हमने क्या लिया है, दैट वी हैव टेकन द दैट then I0 minus I is equal to I0 minus I0 into 10 raised to minus epsilon BC, which is equal to I0 in bracket 1 minus 10 raised to minus epsilon BC. See here, I is equal to I0 10 raised to epsilon BC, which is equal to I0 into 10 raised to minus A. Then I0 minus I is equal to I0 minus I0 10 raised to minus epsilon BC. Okay. See, just arrange that equation. See here on expanding this equation number 4 gives an exponential series as उसको अगर expand करते तो exponential series इस तरह से देता है 1 minus 1 plus 2.30 epsilon bc minus 2.30 epsilon bc upon 21 that square that 21 2 factorial. It is an factorial. It should be an factorial. Just okay. Here 3 factorial. Okay. Okay. ये factorial में उसको expand होता है when epsilon bc is small and approaches to 0.05, that is epsilon bc is equal to a is equal to 0.05, that epsilon bc is equal to a into 0.05. This is the equation number 5. This is the equation number 5 that will reduces to f is equal to 2.303 k I0 epsilon bc. This is the equation number 6. And if intensity of the incident radiation I0 is constant, then f is equal to k dash c. This is the equation number 7. And k dash is equal to 2.303 k I0 epsilon bc, which is equal to constant. Hence, the intensity of the fluorescence is directly proportional to the concentration of the fluorescent substance. Equation 6 is valid for dilute solution up to about few ppm. This equation is invalid for dissociation, association, or reaction of the experimental substance with the solvent takes place. This graph versus this concentration ग्राफ निकाला है फ्लोरेसेंस is the concentration. You can see the similar graph as the calibration graph as earlier we have seen, that is observed. और सेम आप फॉस्फोरेसेंस इंटेंसिटी को भी आप कोरिलेट कर सकते हैं। ये नोट है, that is a note to you. Scattered light is of longer wavelength than the incident light, and here it is called as the elastic one. ये MCQ के लिए आएगा। Okay. After the fluorescence and the phosphorescence, the intensity of fluorescence and the phosphorescence exhibited by the substance depends on number of factors. This particular intensity of the molecule have been found to change with the temperature and the pH of the solution. सबसे important temperature and pH है. Then the association, dissociation and solvation. I have lecture लेते 5 मिनट बाद. Solvation will also change fluorescence and phosphorescence intensity. Generally, molecule with conjugated double bonds, pi bonds, exhibit the fluorescence or phosphorescence. Intensity of fluorescence is high in aromatic and heterocyclic molecule with electron donating groups such as OH and NH2, but electron withdrawing groups such as NO2COH and halides diminish fluorescence. When an atom of the higher atomic number is introduced into the pi electron system, fluorescence generally decreases and phosphorescence increases. The presence of dissolved oxygen reduces the intensity of the fluorescence. Instrumentation is there for the fluorometry. अब यहाँ पे यूवी लैम्प चाहिए, मर्क्यूरी वेपर लैम्प इज यूज एज दिस पर्टिकुलर सोर्स. देखेंगे आप ये जो है सिंगल बीम filter fluorimeter is there, double beam fluorimeter is there, okay, then phosphorimeter is there. Comparison है fluorescence and phosphorescence का. Then scattering of radiation के ऊपर अफेक्ट करने वाले फैक्टर्स चाहिए. ओके, इसका इंस्ट्रूमेंटेशन जस्ट देखते हैं. ये डायग्राम है. अभी यहाँ पे जो जो चीजें आपको नजर आ रही है, पहला तो क्या है, यहाँ पे सोर्स है, बाद में कॉलिमेटिंग लेंस है, फिल्टर है, देन लेंस है, फिर सैंपल होल्डर है. मतलब क्या होता है, सोर्स से आने वाला लाइट कॉलिमेट होता है, कॉलिमेटिंग में से प्राइमरी फिल्टर में जाता है, फिर इसमें से सिलेक्टेड वेवलेंथ जो है ये कन्वर्जिंग लेंस में आती है, फिर यहाँ से सैंपल में फॉल होती है, फिर से सैंपल में से आने वाला जो रेडिएशन से दैट फॉल्स ऑन द कॉलिमेटिंग लेंस एंड देन ट्रांसफर टू द सेकेंडरी फिल्टर, then converging lens and finally to the detector. These are the basic parts of this particular fluorimeter. तो क्या होता है, आपको पता है कि light from the source is passed through the collimating lens and then through a primary filter. This filter transmits that part of the beam which will excite fluorescence. The selected light passes through the sample solution placed in the sample container. The sample emits fluorescent radiation in all directions. This beam emerges at right angles to the direction of the incident beam. The emitted radiation reaches a secondary filter which isolates fluorescent beam from incident radiation. After passing through this filter, the filter radiation receives as PMD. The current generated is read on the same detecting device called as a galvanometer is used. Okay, which gives you the fluorescence intensity. This is the instrumentation of the single beam fluorimeter. Okay, and you can similarly you can see a double beam fluorimeter. सिर्फ क्या है कि सैंपल और जो आपका ब्लैंक है यहाँ पे आने वाला है, that we will see in the next lecture. Here we will stop. Thank you.